Hi, everyone. Welcome to this interview with Dr. Logan Song, the author of one of the best-selling books on Amazon, The Self-Taught Cloud Computing Engineer. So cloud computing is advancing extremely quickly, especially with recent achievements on data science, machine learning, as well as I'm sure you guys all heard of generative AI and ChatGPT and so on. So we really appreciate this opportunity with Dr. Song today to answer some of the questions from our viewers and our audience. So a little bit of background about Dr. Song. Dr. Logan Song is the Enterprise Cloud Director and Chief Cloud Architect at Dido. He has 25 plus years of experience, and he's highly skilled in enterprise level information technologies, specializing in cloud computing and machine learning. As a world-level cloud expert, Dr. Song holds all of the cloud certifications that you can think of, which includes AWS, Azure, GCP, and OCI. He made numerous speeches at various international conferences, including AWS Tech Summits and Google Cloud Next. And he has published 2 cloud books on Amazon, which the viewers and audience can check it out after this video. And I'll drop the link in below of this video. Currently, he is also an adjunct professor at University of Texas at Dallas, teaching cloud computing and machine learning courses. So welcome, Dr. Song. It's my absolute pleasure and honor to have you here today.
Sure. Thank you for having me here, Yichang.
Excellent. So I actually did a previous video on one of your cloud books, and after the video, there's a lot of feedback, a lot of questions from the viewers and audience from various sources. Some of them are students, some of them are working professionals, and we are just super excited to hear about your opinion.
Fantastic. Let's get started.
Cool. So let's start with just general questions about cloud computing. So first question is, what exactly is cloud computing and where does this thing even come from?
This is a great question to get us started. So you know that in human history, right, invention of computer is one of the most important thing, right? If you look at now, like, computers is everywhere. It's really changed our lives, right? And then as you know that the first computer came to Earth in 1946, right? It was in the University of Pennsylvania. It was a giant of 50 tons occupying 1,800 square feet, right? And after the invention of the first computer from 1946 to 1996, in about half a century, we have made it smaller and portable, right? Such as the desktops and laptops we can carry around, right? However, during this evolution, computers, actually the components do not change, including the CPU, the memory, hard disk, and networking, right? And then from 1996 to 2006, 2 things have happened, all right? The first was virtual machines, right? So, VMware had invented VMs. We call it VM, virtual machines. And, we can build many virtual machines from the same hardware. That's actually a big revolution because originally, we are tied up with the physical machine, but now a virtual machine is really just a bunch of files. So I still recall the super excitement when I was moving a virtual machine from a physical host in Manhattan to another physical host in Jersey City, right? You think about, it's live moving. The end user, who is using the web browser or applications running on that virtual machine have no idea, about the virtual vMotion, right? So that was really exciting. And then the second thing that happened is, that Amazon, right? Amazon.com really, like, in 2006, it was a bookstore, right? It's a famous bookstore. And they have some spare computing powers, right? They wanted to share with the other companies. And that's just a project, right? A small project, but it turned out that those 2 things give the birth of cloud computing, which have grown up so much, right? This year, it's about $500 billion business now, right? In 17 years. right? Honestly, when I joined AWS in 2016, right, my first shock was that, looking at the fat invoices AWS charging was charging the big companies, including Intel, Citrix, right? I was like, oh my God, it's just so many people are using cloud, and it's just so big a business at that time.
That's awesome. What a story. So, you mentioned that there's virtual machine and there's cloud, and companies are moving to the clouds. Why do you think is the reason that all these companies are now moving to the cloud? Like, why can't we just do things locally? Like, what's the motivation there?
In 17 years, right? Cloud computing from a small business idea of renting some computing power to other companies, right? It was able to boom so much, right? And many companies are moving to the cloud. There are many reasons, of course, right? And including of them is, cloud computing have the features of virtual, global, on demand, and reliable and scalable, and in a pay-as-you-go fashion, right? So you see that cloud computing is global, right? AWS, Azure, and Azure is Microsoft, right? And then Google Cloud, they are all have global infrastructures, right? So if you want to build a data center, right, you can build it anywhere on Earth. Many international companies, they want to build, for example, build a data center in North America, in Asia Pacific, in South Africa, wherever you want to build, right? That's wherever you want to build. And also, this cloud computing thing is on demand, which means that you can build a data center anytime, right? And you pay only for what you use, right? My second shock when I was joining AWS was that I was watching my co-worker, right? He was, from his laptop, right, connecting to the cloud account, running a CloudFormation script, okay? And he was able to build the data center in a couple of hours, right? Including networking, virtual machines, clusters, databases, Hadoop, clusters, right? I came from the Wall Street background, right? So I was working in traditional data centers. I was in Manhattan, right? So it used to take such, a long time, right? It took months and years to build a data center, right, in Manhattan, right? And also after you rent a place or build a place, then you need to purchase and install the machines, the networking, the switches, right, or the hardware and software, right? And it's of course it's going to cost you a fortune to do that, right? Including the renting, including the purchasing costs, right? So watching my coworker, build a virtual data center, globally, right, and in a couple of hours, really shocked me. And then I think that's, the time, right? The cost, right? Because it's pay as you go, right? And the flexibility, right? That's all other reasons for companies to move to the cloud, especially startups, right? Without a big investment, right? They don't need a data center, right? They just go to the cloud and launch the hardware and the software as needed, right? Virtually. So that's the reason really behind it.
That's really fascinating. So we're talking about building data center and really just trying to make life easier for employees and consumers and other people within or related to the organization. Now, the pressing question here is, okay, if all the data is on the cloud and seems like it's making it very easy to accessible and for other people, is it safe? Like the data safety, is there a concern here? And if there is, what are your thoughts on the data safety when you move things to the cloud?
Oh, believe me, it's a big concern. It's a big concern. And that's actually one of the reasons that some people are still hesitating, young companies are still hesitating to move to the cloud, right? And very interesting, right? It's very interesting that many companies who have moved to the cloud have told me, right, that their data center is actually safer in the cloud than on-prem. I was thinking about it, right? The main reason is that, the cloud service providers, we call them CSPs, right? Because they're big companies like Amazon, Microsoft and Google, right? So they have mature and advanced cutting edge security services and tools. They provide automation, machine learning, right? All these advanced tools for security, right? For example, right, AWS uses machine learning services, right, to monitor the cloud resources globally. For example, the account, right? When Amazon enable a service called Guard Duty, then Guard Duty is going to do some baseline discovery. For example, this company, this account, right? They usually work a busy, have busy activities on the weekdays. However, during a weekend, Saturday or Sunday, then there's minimum activity going on, right? But if some weekend, right, things that happen, a lot of busy, activities, a lot of virtual machines, EC2 instances are launched, right? Then something is not right, right? So those kind of things, monitoring and logging and checking, right, automatically, right, using most advanced tools like machine learning and deep learning, then make the cloud data secure. And also, right, you can encrypt your data, right, using your own key with your own, your own way with your own keys, right? When the data is at rest or in transit. All those contribute to the security and why people think that they're safer in the cloud than on-prem.
Just, even me personally, sometimes even we're talking about some sort of passwords or some sort of documents, or even just picture you take with your family. If you save it locally, you switch a laptop and the picture is gone. Now, if you save it on cloud, then it's actually safer because you're never going to lose that picture. You can always be able to find it. So yeah, definitely thank you for sharing that insights. Another question that popped out from reading the book is, it's not just a cloud, right? It's also these derivations or various of the different versions of the product of hybrid cloud or multi-clouds. So the question here for you is, why do all these different versions? Like, what's the motivation here to come up with the concept of hybrid cloud or multi-clouds?
So, people are moving to the cloud, right? Because, they already have their data center, right? So sometimes, companies want to keep some of the data on-prem, right? That's reasonable. Like AWS offers Direct Connect, right? Azure offers Express routes, and Google Cloud offers Interconnect, right? So the connection between the on-prem and the public cloud are very fast, performance-wise, bandwidth-wise, they're all good, right? So many companies actually using, this information superhighway to connect their on-prem with the public cloud, and then it's forming hybrid cloud. Right, so that's from this point of view, and also companies don't want to be they want to be a cloud agnostic, right? In other words, they want to have multiple clouds, right? One reason being, we have AWS, we have Azure, we have GCP, we even have Alibaba and all the other like Oracle. Each cloud have its own specialty. For example, machine learning, right? Google being the most advanced AI company in the world, their machine learning cloud service will be very, very good, and that's their feature, right? And recently, last year, right, we had the ChatGPT OpenAI, right? So Microsoft Azure has integrated this OpenAI, service into the cloud, into the Azure cloud, right? And then, many like AWS have its mature services. So have a multiple clouds in the same company using multiple cloud footages. We will take advantage of the good things, the features of different clouds, and then that's why companies are using multi clouds and hybrid clouds. And the book which I have wrote is really introduce three clouds, right? That way we can learn them all and we use as needed.
That's really amazing. So I actually find the multi-cloud concept very interesting. It kind of feels like a additional layer of security, right? You not just have one place of information at one place, but at multiple different sources. That's really fascinating. So the next question is regarding to the future of cloud computing. Like in the old days, 50 years ago, 40 years ago, it's the size of a classroom. Now we have cell phones, and now we have ChatGPT. What do you think is the future for cloud computing?
Cloud computing has been, and it's still booming, right? We right now, right? We have big data processing and AI development, right? Especially ChatGPT, large language models, right? This the AI, right? The AI right now, the development of AI is really relying on three things, right? One is algorithm, the other one is computing power, in data, right? So cloud computing, right, naturally, it provides the best data storing and sharing platforms, right? And of course, as we said earlier, right? So cloud computing also naturally provide the most computing power availability, right? You
Yeah.
want, example, like the large language model, right? So,
Yeah.
for ChatGPT, right? You will need a lot of GPUs, right? And it's hard for the startups or for even mid-sized companies to buy all these GPUs and own them, right? So
Yeah.
naturally, you would think about the pay as you go from the cloud, right? So naturally, from data storage and data sharing, from computing power point of view, big data processing and machine learning, deep learning, right? Large language model processing, all this will be very good on the cloud platform. So that's why, right? So many companies are using cloud and moving to the cloud. So I would say that the future of cloud computing is truly bright.
Yeah, that's really interesting. Like me personally, I also had similar experience. Like I can't really fine tune a large language model all on my personal computer. Like you have to go to GCP, you have to go to uh, AWS SageMaker to have that computing power. Because otherwise, you have your computer probably just start training and then first 20 minutes start to freeze up, and then you can't use your laptop anymore. So I thought that's definitely very interesting, and me personally definitely had some pain spots in that field. Yeah. So thank you for sharing that. So now the following questions are mostly coming from students or young professionals who are just getting into this field, and they're wondering what are some of the foundational knowledge in computer science? What are something that's essential if someone want to become a cloud computing engineer?
Before I address this cloud computing engineer skill sets, backgrounds, I actually want to, add a little bit about the previous question, right? So, all the clouds like GCP, Azure, and AWS, they have provided so many services and tools for big data processing, for machine learning and deep learning, right? Such as EMR, Vertex AI, right? All the pre-trained model, right? So then they provide the APIs, right? That's another reason, moving to the cloud to do big data processing and machine learning and then deep learning are so convenient and easy. Okay, so now let's talk about the cloud engineer question, right? So what are the essential knowledge and skills you need for to become a cloud computing engineer, right? So I think if you have some basic concepts of computer science, right? For example, from operating system point of view, right? From database, storage, networking, right? Then that's going to be a very good fundamental knowledge, okay, to start with. Right? For example, using myself, my a career development, right? So after I had my PhD in 1992, right, I worked in Chase. Initially my first job was a Unix system administrator and database administrator, right? It's a Chase Manhattan mortgage company, right? So I was doing operating system level and database level work, right? And then I joined Lehman Brothers in 1997, right? So 2 years later, become a network administrator, right? And then later on, I joined JP Morgan, right, to manage the storage area networks, right? So all those things, right, lay a strong background from operating system, from database administration, from networking, and from storage, right? So after that, I was able to work in EMC as enterprise solution architect, right? So this experience built a strong foundation, in the basic skills for enterprise IT, right? Different layers, and then, right, in 2016, when I was joining AWS, right, I had a great, basic, essential knowledge and skills for the data center, right? All layers of it, from server, from database, from networking, from storage area networks, right? So cloud computing is nothing but, right? It's a virtual global, data center, right? In the cloud, right? It's just that you don't have to touch the hardware, but everything is virtual, right? And it's flexible, it's disposable, it's on demand. It's just whenever wherever you want to do it, you can use them, right? And it's pay as you go, right? So I think if you can have some background on that the IT infrastructure portion, that'll be great. And because cloud computing is such a young industry, right? There are so many opportunities, right? Really, it's a great time to jump into the cloud, right? Look at my career, right? After I joined AWS in 2016, right? I transitioned from traditional IT to cloud computing, right? Within 7 years, I was able to start as a technical account manager to a principal architect and chief architect and cloud director, right? So back to your question, the basic computer science knowledge and IT infrastructure skills would be a great asset for you to start cloud computing and transition to the cloud computing career.
That's really fascinating. So to know the foundational knowledge, that's one thing. And then for students to gain the practice and the practical knowledge, that's another thing. So Professor, I'm curious, for the students out there, and even myself included, to find a job, that's one way, of course. But what are some other ways that the students can gain the practical experience on cloud services without even working in a large-scale cloud environment?
Yeah, wonderful question, right? So it's always a chicken or egg thing, right?
Okay,
we need the skills to find a job, right? But
exactly.
we without a job, how do we gain the skills, right? So the beautiful thing about cloud computing is it's so easily to access it. Okay, so I used to teach Linux and teach storage area networks, like for example EMC storage, right? The Symmetrix, the DMX, it's a huge thing, right? It's not very easy to get access to that. So, but with cloud computing, it just overcome these barriers. Okay, so basically, right? If you register with AWS or Microsoft Azure or Google Cloud Platform with an account, right? We call it a free tier account, right? Then that provides a basic but good enough platform for you to practice. Okay, so without really working in large scale cloud environment, without a job in cloud computing, you can practice it, right? So
Yeah.
with almost no investment, because I know I think Azure and Google Cloud, they provide some credits for you to start. Okay, so give you like probably $200 and $300 to start up was the cloud provisioning, right? Practice the cloud
Yeah.
services. And then with the free tier account, you can touch and build a cloud environment, right? So that's actually also the reason and the purpose of my book, right? The self-taught cloud engineer, right? So, if you get a free tier account and you follow the steps of the book, right? It's just so easy to gain and practice in the cloud. Okay, so as you know that I'm actually teaching cloud computing at the University of Texas at Dallas, right? Our program enrollment, right? I have started teaching in 2019. The first class I had 25 students. In 4 years, right now our program have about 253 students enrolled. Okay, so
Wow.
you see the big demand, right? But it's still very limited, right? So what we want to do is expanding cloud computer learning from the university classrooms to everyone's desk, wherever, whenever they can read, they can think, and they can practice cloud on Earth, right? That's really the intention and the purpose. And I want to thank you, Yiqiao, for helping reviewing the books and then contributing to help our readers and our learners to get familiar and become masters of cloud computing.
Of course, I'm happy to help. It's also for my own experience as well, because when I was in school, to be honest, we learned math, statistics, probability theory, right? But I never had a cloud computing courses from school. And I've always found that part to be a bit challenging because when I start my job in the industry, I actually have to learn all of that on the job. I actually have to figure out, okay, this is how you turn on SageMaker endpoint. This is how you write a Lambda function. you can view your data set in Athena. You don't have to open in Excel spreadsheet, that sort of thing. So, but it turned out that these things are not really difficult to learn per se. You just need the right guidance. And I feel like this book definitely served that purpose. And unfortunately, I didn't have the opportunity to learn this class when I was a student at school. But now that since this book is written and it's out there, I felt like, definitely I would want to share the words with, all the students out there. Please, check out this book. It will definitely give you the hands-on experience to, not just to land the job offer, to, get the job, but also to do the job well so that when you do your onboarding, people don't have to spend the extra time and energy to teach you how to open a Jupyter notebook on SageMaker. You don't want that, right? And I feel
Yep.
like this definitely, gets the job done and definitely serve the purpose. Yeah.
It's actually interesting, right? I just finished a lunch with a bunch of high school students, right?
Oh,
The high school students, right? They are they're close into the Thanksgiving break, so I was able to have lunch with them. So many of them actually bought the book and started learning
oh,
cloud computing. Yeah, because it's so easy, right? You open a free tier account, and then
yeah.
the book is very step by step, right? So they were telling me like the book is really are written in such a way that they can learn it themselves. And then of course, if they have questions, they can always reach me. So I find it amazing. We want, build our future leaders, right? Technology and business from high school students. And this is really a good start for them.
Yeah, absolutely. And it's also a very good evidence that, Professor, you're sharing that. High school students, we're talking about age 15, 16, 17. So if age 15 to 17 students can kind of understand the steps and follow steps in the book and do something out of their free tier account, then if you're undergrad at Princeton or if you're undergrad at Columbia, you definitely have the brains to figure out how to work out the steps. So I feel like this book is definitely very hands-on and explain things in very detailed yet straightforward way. It's not to complicate things. It's really to make things easier for people to follow.
Yep.
Cool, awesome. So after reading the book, I noticed very clearly that there's AWS, there's GCP, and there's Azure from three different companies. So one of the questions from the audience is, Professor, what do you think are the key differences between these three cloud servers? If you want to be a cloud engineer, what's the main difference you have to understand amongst the three?
Yep. So I came across similar questions all the times, right? Students ask me, which one should I learn, right? Which one is the best for the job market, right? All those questions. Yeah. So before addressing the difference, I want to actually address the commonalities, for them, first, right? So cloud computing, right? All the basic concepts are the same, right? Virtual machines, computer spectrum, right? And then storage, right? S3, GCS, right? And then networking, right? VPC and VNets, right? And
Yeah,
all this, yeah, the basic concept is the same. Of course, sometimes they name it differently. And for example, networking, right? The AWS and Google GCP, they actually using the same term, virtual private cloud, VPC, right? But there are some subtle differences, right? So, for example, AWS VPC is regional. Google Cloud VPC is global, right? So when you create a VPC network in AWS Cloud, right, then it is in whichever region you created, right? But with Google Cloud, right, that VPC network is global. In other words, you can have one subnet in Asia Pacific, another subnet in North America, yet another subnet in South Africa, for example. So the virtual machines you put in the same VPC are actually global, and they can talk to each other, within the same VPC, right? So actually, when I teach cloud computing, to my students, whatever, right, college students, graduate students, and high school students, the most important thing I wanted them to learn is that first, mastering a cloud, like for example, AWS, right? Because that's the earliest and the most mature cloud, right? So understand it deeply, right? Do everything you can with AWS. If you want to expand to the other clouds, right, such as Microsoft Azure or Google Cloud Platform GCP, then you learn by comparing, right? For example, right, I kind of compared the VPC concept of AWS and GCP, right? So you compare them, right? Compare them. What's the difference between the virtual machines, right? GCE versus EC2, right? And then the networking storage, right? S3 versus GCS, right? So then you compare the common things and distinguish the different features, right? So in my book, I actually used exactly the same way to do it. So that's how if you go through the book, you'll have a clearly understanding. You learn one first, deeply and in detail, and then the others learning will be just a piece of cake.
That's really fascinating. Well, I'm gonna make a connection of my own low-level experience. Like, for example, if I'm a master at Excel spreadsheet and I know all the fancy formulas, I know all the VBAs. If I go to Google Sheets on Google Cloud, then it'll probably make my life easier because I'm not first time to play around with the rows and columns and the formulas and all that stuff. So I think it's very interesting here, Professor, that you mentioned this concept of compare and contrast, right? You don't want to just learn all of them. Like, pick one, learn that, do that well before you move on to the second one, the third one. I think that's a very good suggestion for the students out there, especially if they're looking at this field for the very first time. So now that we talked about all these cloud are available for us and people can register for their free tier, we talked about the difference. Professor, what do you think is the most important programming languages? Or maybe not the most important, maybe the top three most important programming languages out there for someone to become a cloud engineer?
I think, cloud engineer, right, really depends on how you do it, right? For example, if you are more towards machine learning on the cloud, right, then Python is probably the most important one for you, right? Or if you're focusing on, cloud database, right, such as, RDS, relational databases, or, SQL, then SQL language, right? Structural query language would be the most important for you, right? So I think the answer would be depends. But if you are familiar with Python, with some scripting things like Terraform, Ansible, and SQL, I think that's really good enough for you to be a good cloud engineer.
That's very interesting. I think in drawing from my personal experience, I use Python mostly on a day-to-day basis, just simply because I do most data science, machine learning related tasks in my day-to-day work. But when I started in school, I actually started with R programming language, which is not really applicable to some of the services that I use today on AWS. And then later on, when I started working, I actually learned SQL. So, I didn't really get a chance to learn SQL from school. I really didn't get a chance to learn Python professionally at school either. So I thought, for the audience out there, SQL, Python, these languages hopefully should be able to get you started. To get into AWS, just get your hands dirty. I thought that was definitely a great suggestion from you, Professor. So the next question is, how important is it to have a deep understanding about networking concepts if I want to get into cloud computing? Or can I just, push buttons and all that stuff? Or do I really have to have that deep understanding of networking concepts?
Yeah. So networking is one of the most important areas in traditional on-prem data center in cloud computing, of course, right? Because without networking, one computer doesn't work at all, right? And so I would say that a deep, good understanding of the networking is going to be a big plus in your cloud computing journey. Okay, some basic stuff like such as IP addresses, right? CIDR notations, firewall rules, etc. Right? But I want to point out that in the cloud computing domain, right? It's actually much simpler than on-prem. I still remember the CCIE, right? Cisco Certified Internet Expert, right? That certification, right? I was actually a CCNP and CCIE in storage networking, right? But you know how difficult it is, right? When we go with CCIE routing and switch, right? I still remember that the time, I went to North Carolina, fly actually to North Carolina, stay there in the hotel, and get up in the morning, 7 o'clock, go to the lab and do the CCIE, right? So luckily, right, we don't have to do all this because in cloud computing, right, we really, as a cloud engineer, we really don't touch a lot of the routing things. Okay. So I'm happy to say that, networking in the cloud world is actually easier. Right. So it's a good news, right? As long as, you have the basic knowledge, of networking, that's good enough. And then, of course, this is very important. Networking is always important, right? When you go deeper.
Yeah, absolutely. I'm sure that for the audience out there, you guys are all going to find it helpful to be a good cloud computing engineer if you have a stronger understanding of the networking concepts. So earlier we talked about data safety being a concern when you migrate from local work on prem or onto the clouds. So now the next question is, what are the best practices to ensure security and even compliance on the cloud?
Yeah, there are a lot of things there, right? Each cloud has their own, security services, right? So the book has detailed many best practices for security and compliance, okay, of each cloud, right? And I want to point out that, one of the best practices is thoroughly and deeply understanding these CSP's security services and tools that they provide for security, right? So essentially, security, in cloud computing, we have a model, right? So security of the cloud, right, including the global infrastructure and the hardware, data centers, all this belong to the CSPs. Cloud service providers, right, such as AWS and Azure, Microsoft and Google, right? As a customer and consumer of cloud computing resources, then the security in the cloud is your responsibility, right? And at the same time, right, CSPs provide very good and full scope security and compliance tools. For example, right, I want to give you an example. AWS, right, they have something called a guard duty service, right? And that actually bring I want to talk about some experience I had in AWS, right? So when I was working at AWS, like in November or December of 2017, probably like 6 years ago, same time, right? We're close to Thanksgiving now. So a big AWS client, right, which I was managing at that time, they have about 400 plus accounts, okay, and then their accounts were invaded by offshore hackers. Yeah, so that was it was a weekend, right? Of course, and then the AWS security team actually detected the anomaly of some of the accounts, right? They have 400 plus accounts, but I think it's 3 accounts they were hacked, and they had noticed that based on the machine learning the patterns of this account, right? They don't usually have a lot of activities in the weekends, right? I
Yeah.
had mentioned earlier, right? But all of a sudden, right, that weekend, okay, a lot of activities are going on, a lot of EC2s were launched on different regions, right? So AWS actually notified the customer, right, using the contact information they registered in their accounts. Unfortunately, the information they left with AWS was their company emails and phone numbers. So coming Monday, when they came back to the office on Monday, they found that what happened, right? So the one of the things like they did not use well was the guard duty service, right? So after 2 incidents, right, I was able to get involved and had meetings with them, and we were able to work together and develop a we call it a threat auto notification and auto remediation ecosystem. We enable the guard duty, which monitor the account, right? For whatever invasion, it's going to uh, uh, generate the findings and
Yeah.
also generate a CloudWatch event, which can be used to kick off the notification services and the remediation services, right? By cloud Lambda functions, right? And Lambda can be used to modify the security groups, the network access control lists, right? So that it can kick out the bad act out and protect the networking, the cloud environment automatically. And that was a big achievement at that time. And then that system actually kicked off when the attacks attacked again in March of 2018. So that was a very good experience. So back to your question, I think, understanding deeply and using the cloud service providers, security tools and services in good, manner, that's one of the best practices I want to mention here.
That's really amazing. Thank you for sharing that. So it's kind of like some sort of anomaly detection, right? Because people work from Monday to Friday, people go home Saturday to Sunday. So whatever the activity is going on, the volume ought to be much smaller over the weekend than comparing with the weekdays. So I thought that's definitely something very interesting. I don't know if your project has that machine learning component inside.
Yeah, it's already in guard duty service.
Cool. That's awesome. That's definitely fascinating. Yeah. The next question for the students out there is people are really curious about how to stay updated with the development. As we see from past years, decades of development on cloud computing technology, things are going at a tremendous speed. So the question for you, Professor, is how do students or cloud engineer stay on put, stay current with the continuous updates out there?
As you said that, it's progressing every day, right? Every day, AWS, Azure, and GCP, they have new services. And if you let them, it's like the spectrum is getting larger and larger every day, right? So one of the things we do is to keep up is we need to be aware of what's going on, right? We join community discussions, right? Each cloud actually provide their communities, right? AWS, Azure, GCP, Oracle, right? All this they have their own communities. Number two is they have annual meetings, right? Like AWS reInvent, right? And GCP Next, right? Google Cloud Next, right? So try to participating all this community discussions, annual meetings, conferences, and pay attention to the blogs, right? Actually, each cloud, right? They have blogs talk about the new services. Now we can do this. Now we can do that, right? The cloud service providers, they are coming from the customers, right? So they have roadmaps to add new services, to improve existing services based on customers' feedback. And that's why cloud computing is good, right? It's constantly changing. It's constantly providing new services. And as a professional in cloud computing, we need to keep up. We need to be involved. We need to be aware of all these things.
So for me, I've actually unfortunately never been to GCP or Azure Dev Day or Open Discussion Day or any conferences. Me personally, I've been to the AWS reInvent, and then I think a couple of months ago, earlier this year, they had an AWS Summit in New York, which fortunately I have a time and I went there. It's really amazing. It's a lot of people gather together within the community and just talk about all sorts of different things under the same roof. So it's really fascinating. It's not just students and AWS, right? It's also small business owners and small entrepreneurs or mid-sized entrepreneurs who are using the cloud service from AWS, and they got together and they can talk, they can debate, they can discuss the things, AWS modules that they've been using that's helpful for running their own businesses. So, for the audience out there, if you haven't checked out any of these conferences, please check it out. And Dr. Song, I think you are one of the speakers. You've been to AWS, been to GCP, right? So,
yes.
By going to all these conferences, you also get access to hear all these industry experts, such as Dr. Song, who's giving a speech and, to experience where they've been coming from and their stories. So I definitely thought that's something interesting and recommend to all the viewers and audience out there. So we have one last question. That's about certification. Leave the best question to the end, right? So, Professor Song, what are the certifications out there for people who are interested in becoming the cloud computing engineer? Like, how should they start? Like, do they take AWS, GCP? Like, what are your thoughts on that?
Yeah. So, great question, right? So certification is always a great thing, right? I actually, in my book, I have chapter 16 of the book for this cloud computing, self-taught cloud computing engineer. And then actually the other book, the journey of becoming a Google Cloud machine learning engineer. Certification, the way I view it is, it provides you questions, right? So during the learning journey of anything, right, including cloud computing, asking questions is the most important thing, right? Without questions, you cannot go deeper. I think, if I remember correctly, Dr. Jeff Hinton, right, Jeff from University of Toronto, he was regarded as the father of deep learning, right? In 2012, he brought the neural networks into deep learning. He was saying that, during one of his seminar, he said, the future will rely on some graduate students that seriously doubt everything I said today, right? So you got to, dig the questions, right? Without questions, you're not learning, you're not thinking, right? So that's why, certifications, right? They have practice questions, they have the guidelines. They are providing a great opportunity for you to learn and study the questions, right? Those questions make you think, make you go deeper, right? So the I for all kinds of means that we needed to go and take the certification exams, right? That's just a good a measurement of whatever we learned, and also its integration of all the knowledges and skills we have learned in cloud computing, right? As a matter of fact, in my graduate student class of cloud computing, I encourage students to take the certifications from various cloud service providers like AWS, Azure, and GCP and Oracle, right? And if they pass the one certification, right, I will give extra credits for that. Right. So yeah. So I think it's been very effective, right? So that's the question is it's not really a question, right? We have to do it. The more the better. So I myself, I benefit so much from taking the certifications because they inspire me to think more, to dive deeper.
That's amazing. Yeah. So, for the viewers and audience out there, Professor Song has all of his certifications out there, and please read chapter 16 of introduction for all these certifications to find the ones that's a good fit for you if you want to be a cloud computing engineer. So that will be our time for today, Professor Song. Thank you so much for being here with us. And I was just wondering if there's anything in the end that you want to share or add with the viewers and the audience out there.
Absolutely. Thank you for hosting this session. And then one thing actually, last but not least, I want to share an old saying, right? So basically that says that the more I learn, the more I learn how little I know, right? So which means like, in any learning, right? The more you dive deep into it, the more you feel it's so wonderful word, right? You see a new word, and the more you see, oh my God, I just knew so little there, right? As a matter of fact, right, this old saying was the essay topic my daughter wrote when she applied to Princeton University, right? In that essay, she actually wrote something about her experience in playing games, right? The more she played, the more she felt that she could improve, right? So it is the same in any learning, including cloud computing, right? The more you learn, the more interesting you will feel about it, and the more you feel that you can learn more, and you sure learn more, right? So I just want to share that. and encourage everyone to go deeper, to go broader, and to learn more. And you will feel, more fascinating, and you have the desire to learn more. Thank you.
Yeah, thank you. That's awesome. And not just for the viewers out there, even me personally, I will definitely take that recommendation to heart, keep my eyes out there, and just continue to learn. And also to resonate with all the amazing development out there, Dr. Song, if there's a third book that you want to write, please write a book for us, and then we would love to, just keep learning from you, considering all the developments and all the updates out there. That's really awesome.
Very interesting, right? You mentioned the third book. So for me, like the more I write, the more I feel how little I know.
Yeah. Thank you so much for your time. And, again, for the viewers and audience out there, if you haven't already, please, do yourself a favor, check out the book by Professor Song. One is A Journey to GCP, Cloud Computing Engineer. And then the other book is a more recent one, Self-Taught Cloud Computing Engineer. Both books are available on Amazon, and I'll drop the link in the video below. Please check it out. That's it for today's interview.
Yeah, thank you, Yichao. And everyone, happy learning, and I'll see you in the cloud.